A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with two more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the four of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Doppler on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard.
Going to the beach in winter seems like a good plan. You can have a bonfire, build a sandcastle, search for shells, or swim in the ocean. The vibe might make you overlook the dangers ahead of you. Do you really think through the potential risks of paying a visit to the beach in the winter? The number one risk is waves. You might think it's okay to admire the view on the beach a few steps back from the ocean. Now let me introduce you to sneakers. Not the chocolate bar, sneaker, or with another name, sleeper waves. These are oversized coastal waves. They catch people off guard because they occur without warning or trace. These waves are particularly seen in Oregon, United States. People have been injured and at least 17 people have been swept up into the ocean since 2000. It got more media attention in 2011 when a memorial statue was built honoring the two teens faced with sneaker waves in Oregon. So, how come these waves are so dangerous? It's about their nature. They come out of the blue. With big waves, you see them coming or growing big. Plus, they form in the ocean and come towards the beach. These waves appear near the shore. It leaves less time for you to run to a safer spot. Okay, most of the time, they're not huge, as would be seen in apocalyptic movies. Yet, you can never know what nature holds. Maybe you remember this example from Mavericks. In 2010, a crowd was watching the surfing competition. Suddenly, two large waves struck the people on the beach. It broke the seawall and injured more than 10 people. Sneaker waves don't look particularly larger than other waves until they break and quickly reach the beach. They form in a period of 10 to 20 minutes in between soft and regular-sized waves. They can surge more than 150 feet beyond the foam line. Then they reach the land with high power. Plus, they carry lots of sand and gravel with them. Sleeper waves are more commonly seen along steep coastlines compared to beaches with wider and softly sloped areas. People named these waves, not scientists. They observed what waves do. They washed up in a sneaky way. I mean, scientists didn't classify this phenomenon as a distinct sort of wave like they did with tsunamis or rogue waves. There's little scientific research made about them. Researchers say that sneaker waves form in offshore storms. These storms transfer the wind energy to the water surface. The waves carry this energy and then arrive at the beach during times of calm weather. The larger amount of energy they obtain compared to the regular waves that preceded them causes them to go higher up the coast. Imagine you go for a walk on the beach with your dog. The waves gently reach the beach. You play the throw and catch game. You don't know about sneaky waves, so you turn into an unwary beachgoer. What's the risk? Being washed into the water trapped against rocks. Since it's winter, you tend to wear heavier clothes. The sand that sneaker waves carry can quickly fill clothing and shoes, and that weighs you down. How can people enjoy the beach safely? First off, keep your distance if you're on the beach for storm watching, for instance. It might be mesmerizing to see how waves roll in over miles of ocean. The storms hit the shore, and you look at those extreme turbulent swells transform into strong 30-foot-long waves. Finding a higher spot that sees the ocean and waves might be best. Be the eagle, not the crab. Did Confucius say that? The second tip is if you're determined to storm watch, never turn your back to the ocean. Yes, eyes on the water. Lastly, be mindful of which part of the beach you're walking on. Stay away from the logs because they hold water. The water increases their weight. In the worst case scenario, the ocean is powerful enough to roll the logs onto you. Let's assume you're hiking near the ocean. Use the designated trails because park authorities determine them as the safest roads possible. Going off-route can sound charming, but it can be dangerous for you and harmful to the ecosystem in the surrounding area. Now that you know where to walk, you can keep your eyes open about the geological stuff. Like the rocks can be slippery, erosion can rip them off. Yeah, it's better to avoid walking near bases of cliffs and bluffs. You'll never know when a natural phenomenon will occur. It might sound a little extreme, but you may want to check the tsunami evacuation routes of the area you're visiting. Tsunamis are hard to predict, but tides aren't. Tide tables are available online. This natural phenomenon looks harmless, yet it can isolate rocks from headlands and the shore. You probably don't want to find yourself with soaked wet clothes in the ocean for no reason. Climbing up onto the logs might not be the best idea either. Sure, they look heavy and sturdy when you're climbing, but even the smallest wave can take you like a leaf flying in the air. Not just logs, but also jetties are tricky. Sudden waves can make you lose your balance, and you can collapse. Let's return to the scenario where you and your dog are walking on the beach. This time your pet sees shorebirds and chases them. Birds could be there for foraging or roosting. Your dog could interrupt their chill zone. They can lose their energy reserves. Can you bump into creatures hiding under the sand? Some sorts of creatures can be dangerous for you. Better not to poke someone's home. Take a look at this one. It's a horseshoe crab. This one looks scary, yeah, but it's safe as long as you don't step on its spines. So it depends on the type of creature you see, but generally, it's okay to explore the sand with caution. Until now, we look at scenarios where you were on the beach when they caught up to sneaker waves. You could be in the water too. You could be surfing, just like the contestant in the Maverick surf competition, or swimming, if swimming is the new case. Consider these. The temperature is lower, the waves are crazier, and there are probably no lifeguards there watching you in the winter. Swimming with friends is a safe option. Bonus, it's more fun. You should choose your swimming location carefully. Are there dangerous rocky areas? Can you easily go out if there's some sort of emergency? Know your spot. For that, you should check the weather too. Planning has a key role in winter water safety. A quick weather forecast and sea conditions check would do. You can consider buying a tow float if you're an adventurous open water swimmer. It's a flotation device designed to increase the swimmer's visibility in the water. They are lightweight and have fluorescent colors. Alternatively, you can wear a brightly colored swimming cap. We can talk more about the gear. Wearing a wetsuit is wise, as well as wetsuit gloves and boots. You can put your phone in a waterproof pouch or bag. Staying warm is essential in the winter. Don't just jump into the water at once. This can result in cold water shock. It's vital to enter the water slowly. In that way, your body can get used to the temperature. Once you take all the necessary precautions, you can enjoy the beach and explore its offers. What sort of gems can you find on the beach? A mermaid's purse? Maybe. No, it's not the purse of Ariel from Disney's Little Mermaid. That's actually an egg case belonging to sharks and rays. It's made out of keratin, kinda similar to your hair and fingernails. These purses are the place where the embryo grows. The egg hatches and the cases are carried away with the water to the beach. If you want to find one, you can look at the area near the seaweed. Have fun while searching for it! Now, I'm ending this video with a quick joke that's suitable for the cold weather of winter. What did the ocean say to the beach? Nothing. It just waved.
Imagine a 10-story high wall of water with a foamy white peak smashing into the shore. That's the mental image we all have when we think of tsunamis. But is it accurate? And if it is, why don't daredevil surfers ride them? That's a huge wave begging to be caught. Fear of heights, top speeds, because they choose life? Don't want to smack right into a building when that thing crashes into the shore and floods through the streets? But they're supposed to be daredevils. And how cool would it be if you, with your cheeks flapping in the wind, could ride that tsunami right into your 10th floor apartment? Just don't forget to leave the window open when you head out. No, seriously, where would anyone get the idea to surf a tsunami? I know where. Movies. All those disaster flicks depicting tsunamis as monstrous waves. It's like they cut that wave from a summertime fun surfer movie, pasted it into their own, and blew the image way up. And don't forget about that blue-gray filter. There we go, our disaster tsunami blockbuster is ready. Leave it to the filmmakers to overlook the details. Realistically, the difference between tsunamis and surfing waves is as ridiculously huge as that movie wave about to take out that skyscraper. You can surf on a massive wave, as long as it's the right kind. And that surfable kind can even be bigger than tsunamis. Some surfers ride them every year, but I'll get into that a bit later. So, what is the difference between this right kind of wave and tsunamis? Well, in surfing, every wave has a face or wall. That's the sweet spot each surfer looks for to ride down from. Like going downhill on a snowboard, only you aren't strapped to the board and there's always an avalanche behind you. And there could be sharks right under your feet, waiting to clean up whatever's left of you when you wipe out. Sorry, that got a little, terrifying. Surfing's fun, but I'll watch from the beach, thanks. Tsunamis aren't like this at all. Imagine a tsunami more like a giant tide that comes in a matter of minutes. Yes, the water will likely rise 30, sometimes 60 feet higher than it usually does. But it won't do it as a wave with that much needed wall. It'll be something like a hill of water that rolls in. Think of it like a giant gloopy lava traveling over the shore, only faster. No, even faster. Wait, that's even more terrifying than the shark thing. Never mind. For a normal surfable wave to appear, all you need is the wind to blow. Tsunamis, however, are born by some relatively rare events like earthquakes and underwater volcano eruptions. This is also where the difference in force is coming from. Tsunamis aren't always bigger than regular waves, but they are much more powerful. So every time they come, they tend to bring disaster with them. When an underwater earthquake happens, it produces unbelievable amounts of energy that literally punches the water. This energy has to go somewhere, and that somewhere is towards the shore in the form of a tsunami. In fact, next time you're doing the dishes and in need of some fun, you can make your own mini tsunami. Just place your hand fully underwater and move it up and down, even just a little bit. You'll see ripples on the surface. This is what happens in the ocean after an earthquake, but on a much larger scale. Tsunamis gain incredible speed from the ocean bed moving or shifting up to 200 miles per hour. So those things hit land going as fast as an arrow through the air? Well, that's why I said cheeks flapping in the wind as you ride that gnarly wave. But no, seriously, they aren't going nearly that speed when they crash onto the shore. They lose a lot of that energy as they meet the rise of the ocean floor near the coastline and any underwater obstacle in their path. When you surf into your apartment window, you'll only be going about 30 miles per hour. They might slow down, but the wave grows bigger as it gets closer to the coast. Mega tsunamis are those 100-footers that'll get you into your 10th floor flat. The average height for most is only about 10 to 30 feet. Yeah, only. Compare that to a normal surfing wave. It's usually 6 feet high and only goes about 13 miles per hour. That's why tsunamis are still fast and big enough to cause major damage. But the surfing ones are no walk in the park either. Those kinds can be dangerous too. Just like tsunamis, wind-driven waves will rise when they hit an underwater obstacle near the shore. This obstacle, be it an underwater ridge or coral reef, is the main source of danger for surfers. If a surfer can't hang, they'll be dragged into the deep where sharp reefs lie. That and hitting the water doesn't exactly feel like a gentle pat on the back for a job well done. Okay, I get it. You can't surf a tsunami. But we're in what-if territory, where the rules don't apply, and my imagination likes to run wild. So let's have some fun tackling this challenge. First things first. Since the tsunami isn't a usual wave, we need to find a way to turn it into a surfing spot. You know, somehow get it to form a wall. One thing that could work is an artificial obstacle under the water that'll be specifically designed to strip the tsunami of its monstrous energy. Sorry, we'll lose some of that epic speed, but we need to make it rise higher. The obstacle will have to be a massive structure, but still deep enough that our surfer doesn't bonk his head if he wipes out. Next, we need to take further safety measures. In this case, some sturdy gear. Typical surfing wetsuits are made of neoprene, a flexible material that can protect you only from cold water and help you stay afloat. But lucky you! A new technology recently emerged, a wetsuit that can resist a shark bite. It's like Kevlar vests in a way. All the tests show that it can't be punctured with sharp objects, and it prevents bones from breaking. Unfortunately, bruises from blunt impact are inevitable. It's tsunami surfing we're talking about after all. And finally, the board itself. If riding a normal surf wave is a fair challenge of your sense of balance, then keeping yourself on that board while riding a tsunami might just be impossible. Remember what if? Okay, let's throw some stabilizers on that bad boy. There, now you're ready. You're ready, aren't you? Don't chicken out on me now. Come on, people have done this. They do it all the time in Nazir, Portugal. Well, they don't surf tsunamis, of course, but big wave pro surfers go there every year to challenge Nazir swell. And this 30-foot tsunami you're about to ride is just a pup compared to the biggest wave ever surfed. It was 80 feet high, more than twice the height of a telephone pole. Brazilian pro surfer Rodrigo Coja broke this record in 2017. Maya Gabeira set the women's record by conquering a 68-foot wave in 2018. And I don't think that's the limit, because waves in Nazir can reach 100 feet at times. Hey, the reason why waves in Nazir are so big lies deep underneath the ocean surface. This place has one of the largest underwater canyons in Europe. It's a 140-mile-long, 3-mile-deep gash in the seabed that pushes insane amounts of seismic energy to produce massive waves by the time they hit the shore. The canyon alone triples wave heights here, but there's also strong ocean currents and powerful swell winds in this region. So, it's like the perfect storm for surfers who like a real challenge.
A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. And pay attention to any unusual animal behavior. Animals have been known to sense danger before humans do, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. Take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the third floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly, the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes. and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town, block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
Whoa, look at that view. It's a pity about the traffic. Yeah, we'll get a great view from inside the tunnel. What's going on? It's just a traffic jam. I don't know, but it doesn't sound good. Is that water? Yeah, it's probably rainwater. Although it is flowing pretty fast. There's water inside the car! I can't open mine. The water is too strong! Look! Do you see that? The end of the tunnel! We're almost out! The current will carry us out. We're gonna hit in! I'm trying! Help! What happened? Is that our car? That was too close.
Welcome to the virtual helicopter tour. We'll see the most picturesque sights of the city, although this place isn't real, and neither are its citizens.
Oh, wow! What a view! Whoa, it looks like a tsunami is coming!
Oh my cat, you're right. We should get out of here as fast as we can.
Please, tell me that this copter can handle a tsunami?
Don't worry, it's recommended to hide from tsunami waves at a height of at least 130 feet above sea level, and the record height that copters can reach is about 7 miles. Well, at least this city is just a simulation, and no one got hurt.
Hey, where did that fog come from?
It was formed when the wave hit the shore. By the way, the second wave may come soon, and the third one.
Then we should leave. But wait, can't we save those guys on the roof?
Of course. Hey guys, over here! Hurry up!
Seems like I'm safe here.
Nice to see you, honey. We didn't finish talking.
Ah! How did you get here?
You can't hide from me.
Challenge accepted. This roof looks good.
I'm gonna get you. Come on, come to mommy.
Leave me alone!
And speaking of moms, you forgot about my mother's birthday, empty head.
See you never.
Show yourself. Where are my flowers? Where is my gift for Valentine's Day? Why are you so lame?
Finally. She got lost.
Peekaboo!
Oh well. What a wonderful day. Whoa! Did you see that? That was so epic! Wow! Alright, buddy. No time to think. Steal this car and let's try to survive.
Have you ever seen anything like this?
Not really. Look! The water's very close.
We need to get out of here. Now!
I'm doing my best.
Look out! Ah!
Hey!
Oh,
You okay? I didn't break a single bone.
we need to get to a safe space.
This is it!
Look out! Ah!
Hold on! We'll get out of here, I promise! Let's just try to run away from the waves. Hold on! I have a plan B. Oh no, plan B is canceled.
Whoa!
Alright, let's give it a try. Not so fast.
Yeah. We need to get out of here.
I have an idea.
Here we go.
Come here. It's all over. Oh, we're so lucky.
Ava! Another wave!
No, look out.
Ah! It's too strong!
Help me.
This can't be happening! Ava! No! She's not breathing. I'll need to give her CPR. It's 30 compressions in the center of her chest. Then 2 rescue breaths. Come on. I thought I'd lost you.
We can't go back out there.
We'll need to find another way out.
on, this way. Stay close.
We need to be careful. We need to get to higher ground.
Oh no, get out of the way!
I'm not giving up. We need to jump. Let's get out of here. Oh, what a serene morning.
Whoa, good heavens. The meteors. Hold on. I need to move, and fast. I don't like this, but hope this route will work. Stay calm, buddy. All right, what's the next step? Seems like it's my only way out. Let's take this path. It's about to collapse. The world's falling in on itself. I need to reach fire escape ladder. Hope the worst has passed. Wow, that was a close call, thank heavens. I got to move on. Thank goodness. Oh God, it's falling apart! I'm okay. Gotta move on. What is that? A tsunami? Wow, this is definitely my day.
We've all been afraid of the dark at some point in our lives, haven't we? I mean, do you remember getting tucked into bed by your mom or dad after they read you some scary fairy tale with monsters and dragons, or even dinosaurs? But just as your parents were about to turn the lights off and silently step out of your room, you remembered. What if there was something hiding under your bed? Or worse, what if some spooky creature was stuck somewhere in the closet? You could probably get up and check, but it was too dark out there. Wouldn't it be great to have some source of light that would come from within your body? You could always use it whenever you get surrounded by darkness. Unfortunately, as humans, we aren't able to do that. But there are a bunch of creatures out there that can, in fact, light themselves up. That's thanks to a little something scientists call bioluminescence. Animals and fish living in the ocean tend to have this talent more often than others. And you can find these creatures anywhere, close to the surface or deep down at the bottom. 2.5 miles deep if you have a knack for numbers. These creatures use their light for a lot of things, like communicating with other members of their species, luring in prey, and even scaring away enemies. Bioluminescence is basically an organism's ability to emit its own light. Chemistry has a lot to do with it. Such animals use two chemicals, one called luciferin and the other called luciferase. Add a bit of oxygen and bam! Light! Should you ever wonder if you actually observe bioluminescence or if someone just dropped a glow stick in the ocean, be on the lookout for neon blue, green, or even red sparkles in the sea. They're usually spread over a large area. This can even make the water look like glitter or a starry sky. You can thank squid, tiny crustaceans, and algae for this romantic atmosphere. Now, I've got another unusual phenomenon for you. How about a golden waterfall? I'm not kidding, it actually exists, and it's a natural phenomenon. To see it, you have to drive to Yosemite National Park to the Horsetail Fall. Make sure to plan your trip in winter or early spring. That's the only time during the year when you can see this awesome phenomenon. It doesn't need any scientific explanation. It's nothing more than sunlight at dusk hitting the waterfall in such a unique way that it makes it look like a river of lava. Or gold, your choice. That's the reason why during this time of year, the Horsetail Fall is also named the Fire Fall. Unfortunately, this phenomenon is becoming less and less visible within the years, mostly because of drought and other issues connecting with the melting of snow. So, should you ever decide to visit, keep an eye on the waterfall since the effect is very brief. Ever heard of a dirty thunderstorm? It's also called volcanic lightning. Apparently, specialists looking into the phenomenon have yet to fully grasp what it is. When a regular thunderstorm happens, particles with positive and negative charges collide, hence the giant spark we call lightning. It also makes a lot of noise, which you can recognize as thunder. But when a volcano is erupting, some of the volcanic ash particles get electrically charged, and while getting projected into the air with a huge force, they collide and cause electrical discharges. This whole process makes it look like there's lightning coming from the volcano itself. Imagine all that ash, gas, and smoke coming from the crater, and then add some electricity to the mix. It'll make the whole picture look really bizarre. No wonder this phenomenon is called the dirty thunderstorm. Now, how about clouds that look like waves? Those are called asperitas clouds, and they're actually quite close to the ground, unlike your regular day-to-day clouds. The name comes from the word aspero, which in Latin translates to rough or uneven. On rare occasion, you may spot such clouds when the weather is calm, but they're mostly associated with thunderstorms. These clouds appear during unstable atmospheric conditions, and surprisingly, they don't produce rain. Even though they do resemble dark storm-like clouds, they also create random patterns, tricking your eyes into thinking you're looking at the surface of the sea from under the water. Another impressive kind of cloud is called mammatus clouds. What makes them so special is a series of bulges emerging from the base of each cloud. One such cloud enters a level in the atmosphere where the wind direction changes. You can see these wave-like patterns in the sky. Australia is the place for you if you like surfing, but not all the waves you can catch there are made of water. Near a town called Hayden, there's a mysterious wave made out of rocks. This granite formation supposedly dates back to 2.63 billion years ago. That's way before dinosaurs started hanging around the planet. Standing at 49 feet high and 360 feet long, the wave was formed as a result of two processes: weathering and erosion. There's softer sediment at the base of the wave rock, which was chemically weathered by groundwater. Winds and rain did the rest of the job, causing the erosion of the rest of the formation. Its red, yellow, and gray stripes are made of iron hydroxide, carbonates, and other chemical compounds that were washed down by the rain. You've made it to Australia, so stick around a bit more. There's one more location here that seems unreal. You'll need to fly over this one, however, if you want the best picture. In the western part of the country, surrounded by green woodlands, there's a series of lakes. They're all a staggering shade of bright pink. Out of them all, the most famous is Lake Hillier, a 2,000-foot-long reservoir. It's surrounded by both sand and a forest of eucalyptus trees. This makes the cartoon-like hue of the lake stand out even more. One of the many theories explaining the color of these mysterious lakes is connected with algae. These algae appear to gather high levels of a substance called beta-carotene, which has a red-orange pigment in it. Another explanation involves haloarchaea. Those are microorganisms that sometimes look red. Even if you don't enjoy flying, the lakes are great for taking a swim. They're not toxic, even though they have loads of salt in them. This means you'll be able to stay afloat easily, and the water won't damage your swimsuit. During winter up north in Canada, a bizarre phenomenon happens at Lake Abraham in Alberta. Underneath the frozen surface, you can spot some weird objects that look like frozen jellyfish. It's definitely not the case, as these creepy formations are just frozen methane bubbles. Those are pockets of gas that were trapped underwater and got stuck there after the lake had frozen. They appear when leaves and grass fall into the water and bacteria digest them. This process transforms them into methane. This phenomenon is as beautiful and strange as it is dangerous. The pockets of methane can easily become highly flammable. When the temperatures rise during the spring, the ice melts and these bubbles start popping and fizzing. It's a spectacular sight to observe. Picture a lake filled with soda. Remember not to bring any source of fire. It can be very dangerous for visitors. You can check out these types of lakes all across Canada's Banff National Park. Nature often tends to make its own music. Just listen to the sound of crickets at night, or the soothing noise of a waterfall. But in Bucks County, Pennsylvania, there's a strange geological phenomenon which takes nature soundtracks to a completely different level. These are called the ringing rocks, and scientists still can't explain their unusual behavior. If you strike these rocks with a heavy object, like a hammer or another rock, the stones will make a ringing sound, as if they were hollow, but they're not. What makes the ringing rocks even more bizarre, apart from the mysterious sound they make, is that no animal wants to hang around there. Even though the rocks are surrounded by a thick forest, scientists haven't managed to trace any animal activity in the area yet. Even more striking is the fact that despite all the trees around the rocks, you won't find any leaves lying on the boulders. What makes these rocks so unappealing for both animals and vegetation is still up for debate.
If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, You decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass. and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.